Hello. What a great time to start this. I've got my fan, which is quite loud right now, but what I want to do is I want to go over my experience setting up a Python notebook. I think it's not easy to do right, and I think there's a few reasons why. So I want to kind of go over what I've done, how I've set things up, and we can kind of take a look at what that is, what goes into setting up an isolated Jupyter Notebook environment. So you're looking at Visual Studio Code. I'm currently reading a book. I'll probably go into it in more detail later, but one of the projects in the book is to set up an end-to-end machine learning project, and I've started that here. So what we can see, I'll go over each folder and file that I've got, why they exist, and ultimately what gets created and what you need to understand, which is nothing to get started. So before I go into what all these files are and why they need to exist, I'll just start off by loading up a terminal and running develop. Now, you can already see there's a lot of moving parts here, and on the left of the screen you can see this .vn, which means Visual Studio Code is already putting me into a virtual environment that I've set up earlier. So I'm going to just run a command called deactivate right now, just to kind of get vanilla set up here, and I'll run the develop.sh script that I added to this repository, and we'll see a bunch of things start to happen. So a lot of these packages have already been downloaded and installed, so that's what it's saying. Starting up a Jupyter Notebook, and ultimately what it did on my screen, and I'll show you over here, is it loaded up a Jupyter Notebook. Oh, we need a token. This is interesting. Right, so I need a token to be passed in, and we've got that on the terminal, so we'll just use that now. You can see here, lab token, then there's the token, so that's kind of a security measure. It was added in the browser that opened for me, but it wasn't there. So we'll do that here, it redirects, and now you can see that there is a Jupyter Notebook set up. Great, a lot of people can do this. What's the kind of value of doing this? Or what's being brought to the table that might be different? So a few things. If we take a look at the terminal output, and I'll open up OBS so we're showing things here. There's a few things that happen. So after it kind of says, okay, all the requirements, it shows that some files exist. We'll get into what those files are later. It opens up some, or it imports some packages, and then you can see here, it disables MV Classic. We'll understand by the end of this video what MV Classic is and why we've disabled it. And then it starts up the Jupyter server. And here it gives a small warning about how Notebook Shim is not using this Jupyter server extension points, which is kind of the newer Jupyter notebook format for extensions. It's saying it's going to be deprecated. It's got some extensions that it loads well, and most importantly, you don't see a lot of errors that come with a default Jupyter Notebook start, and you see it starts running here. So what would the errors have been? How have we disabled them? What are all the things you need to understand in order to set up a Jupyter Notebook environment that won't reach into your own directories? So one of the problems with the reason why you use virtual environments at all, or VM, and we'll get into that, is to isolate your environment from anyone else's. And the classic adage is it works on my machine, and it doesn't work for other people. Well, why is that? Because package managers and other systems try and get really smart and make caches and put configuration that is only on your machine. So things will end up looking like they work to you, but there's critical configuration or packages that maybe others can't download that you would never know based on that experience being something customized to your machine. So how do we avoid that with the Jupyter Notebook? Because whether you know it or not, the default installation actually configures a lot of things to look into your home directory on your machine, which means while it might be convenient, you can set things all in one place, it actually makes it very difficult for others to replicate your environment because they're not using the same configuration of files. So, what I want to show you first is a quick chart, and we'll be doing the chart in Jupyter Lab. I don't know what the actual, okay, and we'll go to the playground. And I've already got a chart set up, so I'm just going to kind of copy and paste that here, so we can take a look at yes, and we'll do sketch. I just like sketch more, and we'll make this full screen. And can I drag this across? Or is that just the scroll? That's just the scroll. There's no way to, it looks like at least, there's no way for me to drag one of these. But let's export it as a PNG, and we'll just open it. And we'll take a look at it here. So, this, and full screen. So, these are kind of all the things you need to be aware of. Visual Studio Code is optional, but I'll describe it in a moment. In order to just set up an isolated environment with Python notebooks. So one of the things you need to know at the top is kind of how to work with pip. So we'll start probably over here. What is a virtual environment? Well, a virtual environment, it used to be virtual env, which is Python 2. You can still use it in Python 3, but it was this kind of, it was an answer in Python for how you can isolate your project to be able to be used by other people without your own computer being part of the process of making sure that things can run. There's a great article on this subject. I think I get into it later in the develop. I actually link out to all of these different things, but it's just a way to isolate. So there's a good image, and I actually think I will at least open up that image while we talk about VM, which is, oh, I actually don't have it there. So let me pull up this. And where is it? I think that is my browser. I just went full screen here. So we'll open up this, and so SERP API has a great write-up. They had this on Reddit too, but I think one of the best images is this one right here, right? So at the top, and this is a pattern, you'll see it in all sorts of languages. This is why Docker exists, this is why NPM exists, or Yarn, or Ruby gems, or any number of package management systems. Leiningen, if I'm pronouncing that correctly on Clojure, it's if you didn't have a package manager, this kind of isolated vacuum of a world where your application can live, then you just have your own machine. Your own machine becomes that isolated container, and you can't really give your laptop to other people. You can in theory, but it doesn't scale. So what you want to do is you want to say, okay, well, what's the abstraction I can give to other people? And this has been solved in so many different ways, in so many different levels. So at the programming language level, at the runtime container level, at the composition of services that form a Docker Compose unit or a Kubernetes file, it's all kind of the same problem that's being solved, but just in different contexts, which is, well, how can I isolate this thing that I want to share with others or put in production or do whatever with in such a way that it can be isolated from everything else that might affect it? How can I run this? So this is a great image just to kind of talk about the general pattern. And if we go back to this image, oh, no, I actually had it open, didn't I? This image, that's what VM is trying to do. So you can see in here, there's much more in the VM folder. So there's configuration, there's like compiled libraries, there's a bunch of stuff. But for our purposes, what we need to know to start is that there's a bin folder, and bin is the place where all the binaries will exist. So these are things you can run on the command line, and the two that you would expect to like exist to give any value at all was Python and pip. So Python is the language runtime itself, and pip is the Python package manager. There's others, but this is the kind of one that comes with Python. And there's these two shell scripts, activate and deactivate. We'll talk about what those are, and then site packages, and that's all the packages that you install. So you'll have a file called requirements.txt. You don't need it, but it's a useful file to have, so you can kind of list out all the packages that your application needs to run. And it installs, pip installs those packages into the VM's site packages folder. So what this means is you actually get a folder that exists in your project, and its sole purpose is to house binary files, site packages, which are these packages your application depends on, so that every time you go into this folder and you activate this virtual environment, you've got a replicable environment. We'll also talk about constraints. These are also known in other worlds as package lock files, but effectively when you install something, like for instance we have a dependency on Jupyter Lab because we're going to be running the Jupyter Lab server and client so we can start writing notebooks. That's what we need directly. That's a direct dependency our application needs to run, but Jupyter Lab itself has its own dependencies. So transitive dependencies that our dependencies depend on. So in order to ensure that we have a repeatable environment, we can't just have direct dependencies because those will reach out to the internet and they potentially might install dependencies that have updated over time. So you need to have two files. One is to represent your direct dependencies or your semantic dependencies or first order dependencies, and another file to represent the dependencies that get installed by proxy of your direct dependencies, or in other words, the transient dependencies. So constraints.txt looks exactly like requirements.txt. In fact, you could call it, these can be named whatever you want. The convention just to be seems to be that you call requirements.txt because when you use the pip install command, there's actually two arguments we'll see, which is where are your requirements and then where are your constraints. So that's why you just happen to call these files requirements.txt and constraints.txt. But those two things are necessary. Those all go in the site packages. So at the end of the day, if you have these installed, then VM will house these for you inside of the site packages folder. And yeah, bin, I think the only other two things you need to know aside from Python and pip, and if there's any questions, please do write them in the chat, or if there's any clarifications you'd like to provide, do that as well, are two scripts, activate and deactivate. So this is the idea that it's a bit unique to VM in solving this isolation problem, in that you have to enter the isolated vacuum space, right? Like if this were making computer chips, you'd put on your suit, you'd get hosed down for dust, and you'd be in the silicon chip making room. And that's activate, right? So it brings you into that environment. It actually changes your path, which is an environment variable that allows the computer that you're running commands on to understand where commands are. So it searches your path to find where all the commands might live. And venv, when you activate, will make sure that all of the binary files that are in bin in your VM folder will be available and will actually override your system binary files for things like Python or pip. So that's activate. Deactivate just unsets the path environment variables you have. It kind of brings things back to as if you weren't in this environment at all. You take off your suit and you're all dusty again and you're ready to live in your normal environment. So we'll get into that with VM. But already this is a bit more than just starting up a Jupyter Lab notebook. There's a lot to do this right that you need to understand, and we want to isolate this, right? So we want to understand how we might do that. And when we consider Jupyter Lab, there's actually a few applications that Jupyter Lab creates. So one is the server, another is the lab itself, and then it has some configuration for its paths, and we'll talk about what those paths are. So the server is the backend for Jupyter notebooks. It's the thing that runs your kernels and it evaluates code and produces results that ultimately the client will use to represent things like graphs or results of computations. And one of the extensions, and there's a great article, and I'll direct you to the article here, is NB Classic, and that's Notebook Classic, and that was the traditional notebook processor. There's a new one, can't remember what it's called, but it's the modern take on notebook execution via kernels, and you actually have NB Classic running by default, because in certain contexts it will still be used, and it may be used primarily in some contexts if you're using different configurations. We don't need that. We're going to be using the new notebook, or at least we think we will. We'll see how far this gets us. So you can actually disable that extension, and that can let you operate as if you're in, I think it's Notebook 7, which is the newest version, without any kind of backwards compatible options. There's a Notebook Shim, which is actually trying to make sure that existing extensions and other code can run as if it's running in the newer form. So I think the experiment, at least I'm trying to do, is see how far we can get without using NB Classic at all, and whether we can actually do that today and have things work. Another one is the announcements extension. This is just kind of a novelty that you probably do want to disable. Every time you start up Jupyter Notebooks, it'll ask you if you want to sign up for the news. I don't. Or if I have already, I don't want to be reminded to again. This is important because we're not configuring things. We're trying to isolate. We could configure this in a different way, but we're just going to disable the extension itself. So it says announcements. We won't be, unfortunately, getting any announcements, including the news announcements, but I think we'll be okay with that. So that's Jupyter Lab. And by the way, I'm looking here when I'm discussing this. And then there's paths. So paths are two configuration options that Jupyter Lab allows, or Jupyter allows you to set. One is the config directory, so this is where Jupyter will configure itself. By default, this takes on a user directory, which means it is not application specific or project specific. It actually takes a bunch of configuration for Jupyter, and the whole reason for me starting this was it was actually trying to look up some information from another project I was running. I had another folder where I was running Jupyter, and I was confused. I'm like, why is it asking for, or why is it erroring out on files that don't exist when I never told it about those files? And I realized it's both config and data coming from my user directory, and that immediately said to me, okay, well, I need to change this. It's not obvious exactly what to do, so I've got one solution and you can choose your others, but I think this is an appropriate solution to configuring isolated configuration of data. And then data is just data, so any of the information about the runtime or anything in Jupyter needs to run. So we've gone over pretty much everything. We've gone over all of this stuff here. The last thing to talk about is a very odd environment variable and warning. And the creator of Python, I believe, actually talks about why this problem exists. And it's like 5 or 6 levels deep into why Visual Studio Code happens to get into this problem with debugger, debug Py, which is based on PyDevD, I believe. So a whole weird ball of wax, but we'll talk about how we disabled it, why we disabled it, and what that means. So cool. That's everything relating to what you need to know to even start out correctly writing Jupyter notebooks. There might be even more, but I know this at least is something useful to know. So let's go into our developed script and see exactly what we did here. So first off is another thing about the activate and deactivate is there's this idea called moding, right? Vim or VI used to have the, I mean, it does still, Emacs, all this stuff about like putting certain keyboard commands in place, and then you change into like an edit mode or a navigation mode. This was called moding, and there was I can't remember where this person was or what their name is, and I'll try and remember and write it. If you know, please write in the comments. They had a license plate called "Don't Mode Me In." I think Brett Victor talked about this in one of his talks, but it's this idea that like you don't want to have to think about the context in what you're running. There was a great GitLab, I think it was 10 years ago now or 5 years ago, someone deleted the GitLab databases. And the reason why is because they were moded in. They had terminal windows open, and they didn't realize that they were in one instance as opposed to another, because they didn't take a look at kind of the prefix on their terminal to understand that they were in database A as opposed to database B. It's DB1 or DB2, but one was a replica, one was the kind of write-only master database, and they deleted both. So it's moding is this idea that you rely on context as opposed to explicit actions defining how you interact with your environment. So an example is like a car used to have a bunch of independent switches. Airplane cockpits have these where you have a bunch of switches and each one is useful. And the reason why that's useful is in a stressful situation, if you're in an emergency, everything is muscle memory. You know where everything is. If you're well trained and if you've kind of had experience with aircraft. Otherwise, it's very, it looks complicated. There's a great talk, Simple Made Easy, by Rich Hickey that talks about this, but it's actually simpler when each individual thing is located in space. You learn where everything is, and over time you understand how to use it. Moding is that idea of a touchscreen. So a Tesla, you can make great touchscreens, but the idea of like changing the air conditioning, you might have to go through 6 screens, where on a car without a touchscreen, it might be a knob that you can turn on or off or dial in to whatever temperature you'd like. So there's trade-offs with everything you do, and moding is one of those trade-offs. You want to think less about the environment that you're in, you want to think more about what you want to do. So this activate, deactivate, we'll actually take a look at the activate script. So there's a bunch depending on your machine, so PowerShell scripts and others depending on what you are using for your shell. But you can see here, this deactivate is actually a function that gets sourced. So the command you run, if we go back to the develop command, is you run source this script. And what source does is it puts all of the functions and variables that are defined in this shell script into your environment. So because we've defined a function, or because a function was defined here, that actually becomes a command you can run on your terminal. That's how deactivate. So I'll actually show you. So if we do, we'll shut down Jupyter, we'll clear. So you can see here, there's nothing on the left-hand side that says VN. So if I start writing deactivate and press tab, nothing's happening, right? But if I run source VN, then activate, right? What's going to happen is it's going to source this function, and I'm going to be able to first see that I'm now in my VN. It does this as a convenience. You can see down here, it changes the shell. So PS1 is a special variable. It just allows you to update the text that you can see on your terminal. And here it's setting it to the environment that I'm in, which is this VN prompt. It's taking on this VN folder name. And I'm now in the environment, and I have, you can see, just so we know, there's like this path, and it's keeping it around, and it's setting the path to be the path plus our virtual end path, and you can see it's this whole VM thing that's been added to the path. So that means any commands I run, and actually I'll show you. So if I deactivate, so you can see now I have deactivate because this deactivate function has been added to my shell. So now I no longer have that. I can't run deactivate. There's just a bunch of other things now. But what you can see, this is the whole point of VM, is if I do Python 3, you can see it's using my homebrew installation. And similarly, if I do pip, you'll see pip 3 rather. It's using the homebrew installation. If I run source VM activate and then run Python 3, you'll see it's now mapped. Now what we can do is we can actually run a command, and I will just do this. So what this is going to do is this is going to run, it's going to take this folder name and it's going to ls that folder name, so it's going to list it, and I need to do -l, and it's going to show you what's happening here. So this is actually a symbolic link that maps to Python 3.11, and if we look, Python 3.11 is here, and that's mapping to this file. So let's do deactivate, and there, and you can see now that is also in my environment. So it's really just mapping what we're calling Python 3 to this folder, and it's doing a few other things so that we can get the site packages installed in this directory. So you can see if I go into lib, it's actually not just site packages, it's lib, the Python version, and then site packages. These are all of the dependencies we have, and these are actually what are installed. You can see that by running a command pip freeze. Sorry, pip 3, or actually no, yeah, this is great. So I'm not in the virtual environment, so if I run pip 3 freeze, we see nothing, right? Now if I do the activate command, and then I run pip 3 freeze, you'll see all of the packages that we've installed into our virtual environment. So that's kind of the idea of a virtual environment. It keeps your packages and configuration all isolated to the specific virtual environment. So this is all it is, right? This is the magic, is this script. That's what happens when you source this and activate it. It does a few other things, but fundamentally that's it. So that's activate and deactivate by extension, and it gives you everything in this virtual environment folder as what you can be, and you can see the command and the executable and all this is configured here. So include system site packages is false. So that's venv. That's the whole point of venv. So we can go back to develop. So what we're doing here now, if we understand it, now this is just how we're using, we're setting up venv, and if it's already been set up, it won't be set up again, is we're saying run Python 3. This is outside of the virtual environment, using the module venv, which is an installed module with Python 3, and set up this virtual environment in the directory .venv. That's what this command is doing. After that, we're running this source using the folder here, and actually we can extract that. Folder equals, and we can use that here. And folder, and we can use that here as well. Right, just so you understand that that's the folder where we want to set up the virtual environment. And then we just run the activate script. So that activate script will just ensure that the virtual environment is being used for the rest of this script, because we're sourcing inside of a script, so that doesn't source outside of the script. It's isolated to where the script is running. So that means when we run, and I'll just clear this up, develop, right? It's going to run, it's going to put all these packages, because they're already cached and installed, it's going to say that they're running, but we're running all of this within, and it just ran and it opened in another browser here, but we're running all of this within, for this script, the virtual environment. And you can see that in a bunch of different places, but we'll stop that, say yes, clear. Okay, so that's how you set up a virtual environment, why you do it, how it works, installing the dependencies. Here's where we talked about the requirements file and the constraints file. So you can see here requirement has the file requirements.txt, constraint has the file constraints.txt. So let's take a look at those. So requirements has Jupyter Lab, and we're locking the package version to 3.6.3. You don't need to, you could do this, and this would just install Jupyter Lab, whatever the latest version is. We're just making it a more reliable installation by ensuring that we specify the version. You can add a hash, so you can do it on the same line, but you can also do this. Hash equals 256. I don't know what hash is, but you can do something like that, and then that would be an extra security measure to validate the checksum of the package that you'd be downloading. I've been reading a bit about it. It seems like it's a bit more complicated than it's necessary. What I found is there's apparently an API that there's a PyPy, I believe it's called, API that will give you the JSON results, and that has the SHA. I mean, there's something there, I just don't have the patience. But in any event, this is good enough to get us the, and the constraints file is just after you install it. You can definitely see Jupyter Lab is here, but all of the transient dependencies, so the things that Jupyter Lab depends on, are listed here. This is very similar to a package lock file for NPM, or a yarn lock file for yarn, or I think there's a Ruby Gems variant of this. Everything has something like this in modern package managers to ensure that after all the packages are installed, not only do you have the direct dependencies version locked, but you have all the transitive or dependencies of dependencies version locked as well, which means any other system that would install our requirements would also ensure that it gets the correct version of all of the transitive dependencies as well, to make sure that everything that goes along with the application that we're trying to run, or at least install, is consistent with the person who initially ran this. So there's more to talk about here. If this is interesting, let me know in the comments. I can go into it about how you use pip freeze to kind of create the constraints file. But for now, just know that we had to do this with our requirements and our constraints in order to get a localized version of all of these packages that will run the same way it runs on my computer on somebody else's computer. Some caveats there, but not worth getting into. So here's some URLs that I documented. So this is the official docs on Jupyter directories. This is actually the code where I can see how the directory paths are set up by convention. We'll actually take a look at this because this is interesting to know why I set the data directory to be underneath the config directory. So let's quickly take a look here. There's not much like information that's available on exactly what you should be doing. Let me just quickly turn on focus mode. But here, I'll show you the code. So if we take a look at paths, what's happening, aside from all of this, is... okay, so here's where we set the Jupyter configuration directory. So by default, it'll use this environment variable, otherwise it's gonna look at the platform. So are you on a Mac, are you on Windows and Linux, and it's gonna make a decision. So if it's set, oh, actually this is another environment variable. You can have no config, so this creates a temporary directory and just creates brand new clean configuration. That's interesting, but I can imagine we might wanna have configuration, and we definitely need the data directory, so we don't have access to this directory. So in any event, that's not the path I went down. If it's the config, it's going to use it. Otherwise, it's going to look at the platform directories for the user config directory. So that's kind of the platform specific stuff. Get the home directory, and it's going to see here's what it's going to do is it's going to get the home directory and it's going to path join the home directory with .jupyter, which means by default, all your projects that depend on Jupyter are going to grab configuration from your home directory. And if you're setting configuration, it'll sync it with every other project. That may or may not be what you want. It's definitely not what you would want by default, in my view. What you would want by default is to have each individual project have its own configuration and reverse this. So if you wanted the convenience of having global configuration, global variables, right? That's what this is. You would want to be able to configure it for a convenience. This doesn't do that by default, so that's troublesome in my view. Then there's the data directory. So this is where I made the decision to put the data directory under the config directory. As you can see, it does a bunch of stuff. So it respects the data directory if it exists, and then it goes to the platform directories here. But fundamentally, if it's on Darwin, so if it's on Mac, it's going to put it in your home library Jupyter folder. And again, it's putting all this app data in a pseudo global, so a user global folder, not my preference. If it's on Windows, this is an interesting thing. So it'll look for an environment variable called app data. If that doesn't exist, it's going to return a string for that path. If it doesn't exist, it's going to look for your config directory, and it's just going to put a folder underneath it called data. Well, that's what I chose for Mac. The same thing. I think this is a great convention. take whatever the config directory is and put your data there. So if you decided to make your config global, well then your data becomes global. And if you make your config project specific, well then your data becomes project specific. So I think that's probably the right path for most circumstances, is if you're looking for a global convenience, you get it in both places without having to think about it. And then this is just using XDG data home, which is an environment variable that I'm not, similarly with app data, probably some convention I'm not aware of, really doesn't matter. It uses that, and if it doesn't exist, then it uses your home directory, a completely different convention. For Linux, it uses .local. I mean, this is all over the map. If you're on different machines, the convention is wildly different for each machine that you're on, which I'm not a fan of. I think there should be some consistency even across environments in terms of where data goes. And I think that was probably a mistake to make this config and data first global, and then secondly, conventionally different across machines. Because now if you go to a Windows machine, you gotta relearn some of these conventional places. So this is the code. That's why, if you look at our code here, is I just said, we're gonna make the Jupyter config directory, we're gonna take whatever directory we're in, and we're gonna put .jupyter in the same place. We're gonna make the directory if it doesn't exist, and we're gonna export it as that's where the Jupyter config directory is. Similarly, we're going to take the data directory and we're going to make a data folder underneath it. We'll just confirm that there's the data folder in existence. And you can see there's two things here. I'm exporting, and actually I'll do it this way too. I'll make the export a separate command, just so we've got some consistency here. You can do them both in the same command. I needed to use the mkdir. In fact, I needed to do it there too, so I think it's more consistent to do it this way. You can do an export command where you put both the assignment and the export command on the same line. It'll work just fine. But in this case, I think it's actually better to be more clear about what I'm doing. I'm creating a variable, I'm making a directory from that variable, and then I'm exporting that variable into the environment. So I think this is probably the better way to go with the data directory. Okay, I won't really go too much into this. I'll leave this as an exercise, and I'll link the code actually. I think that's probably a better thing than each of these individual files, but this is a great write-up of MB Classic. So who wrote this? This was, I think this person works for Jupyter, but they gave an excellent description about why there's front ends and why the back end needed to change, and Jupyter Server is the new server, and this Jupyter Notebook was a Jupyter Server extension now. So MB Classic was the old way of doing it, Jupyter Server is the new server. And then it talks about like why they exist and what they're used for, and you know, sometimes MB Classic is used, Jupyter Lab will use the new Jupyter Server. So great write-up. But that's what we're going to do, is since we're using Jupyter Lab and we're using the new Jupyter Server, we're not going to use MB Classic, and we're not configuring it to use MB Classic. So we can actually disable that server extension. And it was giving warnings before. It was saying, you know, it wasn't up to date and it's deprecated, or it will be deprecated soon, and it gives you this whole like write-up of like, you need to migrate to Notebook 7. So when you disable that extension, all that kind of warning text goes away, and it's a good experiment to see if we can just write Notebook 7 notebooks. This one, this is just kind of straightforward. This tells you, if we go here, that when starting Jupyter Lab, you'll see this pop up in the bottom right corner, and you can just disable this extension and that goes away. So when we ran Jupyter Labs, there was no pop-up in the bottom right corner. That's because we disabled it. And this one, this is wild. So if you're not using Visual Studio Code, you actually won't see any need for this. But the reason this exists is, if you go to this file or link, so we'll go here. So it says frozen modules are being used, right? And it gives you this, and I was unclear. There was actually somewhere else I was looking, or no, this was it. I think I actually wrote to this. I did. I replied just saying like, it isn't clear why we're you know, because there were a few good comments, but like, hey, has it actually impacted your experience? You get this warning, and a lot of people are asking, well, hey, what does this warning mean? Why does it exist? It's not obvious. So the reason it exists, it's this warning here, debugger warning. It seems that frozen modules are being used, which may make the debugger miss breakpoints. Please pass X frozen modules off to Python to disable frozen modules. Debugging will proceed. Set this file to disable this validation, right? So this is a weird one, and actually, because I read the second one, I think actually using this config is the right approach. And the reason why is if we go here and if we take a look at this, you get to go down the rabbit hole with me here. So this, it says see here, right? And you can see it looks for a weird string where it's less than symbol frozen, and then it writes this error. And if you read here, right, because this doesn't really tell you why that's existing at all, it says something else, right? There's this issue with incorrect compilation on a Mac, M1, and it says some stuff. And then this, I believe this is Guido Van Rossum, yeah, so the creator of Python, I believe. And he's very funny. Core dev here, can you help us track this down? You know, quite a core dev. So he's describing down here, this particular module is frozen. It's just a hack to speed up the startup, and its file name shows this like /frozen, which is why you saw it in the old ticket. This is just a startup speed thing, right? And you can disable frozen modules. Oh, there's my light that turns off at 8:30 or sometime, I think when the sun goes down. Anyways, it's in here. You can disable those by just saying frozen modules off. Now, my thought that does is it just doesn't make them frozen, and it makes it longer startup time, but it'll give you real file paths. So that's really weird, right? That tracks all the way back through, and was actually why I put this guy out on the right, this pydevd, debug py. Okay, so I didn't even get into, like, how is this happening? Well, this is happening because I'm using Visual Studio Code. Visual Studio Code, if you look up, what is the extension? The Jupyter Notebook extension it uses Microsoft's debugger, and it's Py. It's actually in your virtual env. So if we look, it's debug py, right? So if I do a quick search, how do I search here? If I go to the settings, this extension settings, debug py, I think, yeah. So Jupyter, path to debug py, right? But in any event, it uses debug py. There's some configuration, just so you know. Well, what is debug py? I actually can't even say it here. Notebook support, multiple commands, run a debug cell, notebook, blah, 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 telemetry. Anyways, if I go to the browser and I look up debug py, so we're in pydev debugger, right? This is where I start. I'm like, oh, interesting. Why is this? And it's like, well, this is the backend used by pydev, pycharm, and bundled through debug py, which is the debug adapter using VS Code Python. Interesting, right? All these like connections getting us to why we have to change that environment variable in order for us to not see that warning, which is here. And then we just run Jupyter Lab. So exec is a bash-ism. It allows, or a shellism, I suppose, since I'm running in Z shell, but it allows you to say, whatever the process is that's running, I now want to delegate the process to run this command that follows. So there's not two processes. It doesn't spawn a child process to run the command that follows. It just implies that the process that's currently running this script will now be taken over and run by this Jupyter Lab notebook directory command. So that's what we're doing here, is we're executing Jupyter Lab, and this is now the process. And that starts up Jupyter Lab, and all of the things that we need to run this are isolated into this project. So you can see Jupyter, you can see the data folder, all of these are under gitignore. So you can see venv is not something you want to check in the source. Jupyter is not something you want to check in the source. That's our config and our data. You could, but in practice you want to leave that available to other people to choose what they want to do to configure it. And then ipy notebook underscore checkpoints is just this folder that when you create notebooks, it will keep auto-saved checkpoints for all of your notebooks, so you can ignore those as well. So those are the three folders up top. Here's the gitignore we're in now. That's just ignoring those three folders. The constraints file that we talked about, that keeps all your transitive dependency. Your requirements file, this readme that describes how to run, and this develop script that we just went through that defines pretty much everything that you see in this diagram, which is pretty much everything you need to know to even start using Jupyter Lab and the notebooks in a local environment on Visual Studio Code. So a lot. I hope it was helpful. If there's anything you want to know or any additional information that I haven't covered that you think is worth covering, let me know in the comments, and thank you for watching.